Hi students, welcome to Vijay the Gate Academy. So in this class, we will learn about logic gates. Not all logic gates are possible. Mainly we'll see about NOT gate. So the logic gates are the basic building blocks in all the digital circuits. So whatever the digital circuit, whether it is multiplexer or any adder or any subtractor or any flip-flop, if you want to construct any digital circuit, these are the basic building blocks in all the digital circuits. So there are mainly 7 logic gates are there. In that, not and are, these are the, we will call it as basic gates, and NAND and NOR, these gates are called as universal gates. NAND gate and NOR gate mainly called as universal gates, and this XOR and XNOR mainly used for in all the arithmetic circuits. In all arithmetic circuits, in addition to the arithmetic circuits, we can take comparators and code converters, and mainly this XOR is mainly used in parity checking. That means in the digital communication subject we will use XOR for parity checking. Now first we will go in detail about the basic gate, one of the basic gate, NOT gate. NOT gate, it is also called as an inverter. It is also called as the inverter gate. So inverter means which will invert the input. Whatever the input you are applying, you are getting the complement of the output. The symbol for NOT gate is like this. If A is the input for NOT gate, then output is the complement of the input Y bar. That means if the input is 0, the output will be 1. If the input is 1, the output will be 0. Now, if you are using two NOT gates are in cascade connection, if you made two NOT gates are in cascade like this. Cascading means one output is connected to the input of the next gate. So if A is the input, the first output of NOT gate is A bar, and the output of second NOT gate is A bar whole bar, which is equal to A. That means whenever two NOT gates are connected in cascade, that circuit is acts as a buffer. That circuit is acting as a buffer. But in the examination point of view, directly these questions are not given. Let us see one previous IAC question, ESE exam question. In that, the same circuit is given like this. Two NOT gates are connected in cascade, but the output is again connected to a feedback. A feedback connection is present from the output of second NOT gate to the input. Now the question is, what is the name of the circuit? Is it a stable multivibrator or a bistable multivibrator, or simply it is acting as a NOT gate, or it is a basic memory element? There are several options are there. Let us analyze what will be the output of this. Now first let us remove this connection. So when you remove this connection, if we apply the input 1 here, then the output is 0, and the output of second NOT gate is 1. Then that 1 will be applied as input now. So first we will remove the connection. After that, after knowing the second output, then we will apply the input. Again it will be 1. That means whatever the input you are applying, the same output will be available. The same input will be available at the output. That means when you are applying 1, the output is 1. Now let us remove this connection again. Now I will apply 0 now. 0. I will apply 0 now. Now the output of first NOT gate is 1. The output of second NOT gate is 0. And that 0 is connected is again like this. Now that means again the output remains same. If you are maintaining 0, the output is continuously remains in the same state. That means this circuit is having two possible stable states. When the input is 1, the output remaining in the same state 1, and the input is 0, the output remains in the same stable state 0. That's why it is having two possible stable states. This circuit is called as bistable. bistable multivibrator. Bistable multivibrator. And there is one more name for the same circuit. It is also called as basic memory element. Basic memory element. Why we are calling it as a basic memory element means, what if we want to store one in this circuit, that one will be remain up to infinite number of time. Similarly, if you want to store 0 in this circuit, the same 0 will be repeated. The same 0 will be maintained at the output in the infinite amount of time. That's why it is called as basic memory element. So the important point is, to provide bistable multivibrator, you need to connect even number of inverters, and they are connected in cascade with feedback connection. Whether you are connecting two NOT gates or 4 NOT gates or 6 NOT gates, whenever you are connecting even number of NOT gates, that circuit will be acting as a bistable multivibrator. I hope you understood. Next, there is another possibility of question in this using this NOT gate is, whenever the NOT gates are connected in the odd number. Let us consider one situation. In this, an odd number of NOT gates are connected in feedback like this. Then how this circuit is acting like? Again, for understanding the operation of the circuit, first remove this connection. Now I will apply 0 here. When I'm applying 0, here output of the first NOT gate is 1, and again here it's 0, and again here it is 1. Now that will be again connected to the input of the first gate. So what you are getting now, 1. Again that 1 is converted to 0, and 0 is converted to 1, and again 1 is converted to 0. Like this, whatever the input you are applying, but it does not remain same. It is continuously changing, 1 to 0, and 0 to 1, and 1 to 0. That means we are not able to maintain the same stable state. Like this you are getting. Sometimes for some duration you are getting 1 like this, and again after some time again it is changed to 0, 1, after some time it is changed to 0, and again this 0 is again changed to 1, like this. That means the output does not remain in the same stable state. It is the stable state is continuously changing. So there is no stable state at all. No stable state at all. That means no stable output is maintaining at all. That's why, since there is no stable state in this circuit is acting as stable multivibrator. As stable multivibrator. So the question is, the point is, to provide as stable multivibrator, we need to connect odd number of inverters are connected in cascade with feedback connection. Now here the output is oscillating between two voltage levels. Whatever the voltage we are providing for this logic 1 and logic 0, and that will be that oscillating between those two voltage levels. And there are some other names for the same circuit. Is one name is as stable multivibrator, and the other name is, this circuit is also used for generating the clock signal, so it is also called it as clock generator. And one more name for the same circuit, it is a ring oscillator. And there is one more name, it is free running circuit. Without applying any input, the output is continuously will change, freely changing its output. Why it is called free running circuit means, the output is freely changing its output. Now here, sometimes using some numericals also, you may get some question. Let us see how we are getting the question. Let us analyze the same question again. The same odd number of NOT gates are connected in cascade. Now here each NOT gate is having a propagation delay of TPD. Let us assume that each NOT gate is having a propagation delay of TPD. Now what is the propagation delay? A propagation delay means, after applying the input for that particular gate, how much time it is taking to get the output. Okay. Now the output of this astable multivibrator circuit is like this: 0, 1, again 0, 1, 0, 1, again like this. Suppose first we are getting 0, again 0, and that 0 is connected like this. That will be changed to 1, and that will be changed to 0, and that will be changed to 1. So from 0 to 1, how much time it is taking? Total duration of 3 into TPD. So from this 0 to 1, it is taking 3 TPD time. And similarly for again 1 to 0, it will take one more 3 into TPD. Now what is the frequency of this? The time period for this clock signal is T is equal to 3PD plus 3 into TPD. We are getting 6 TPD. 6 TPD is the total time period for the given signal. Now sometimes we are asked to calculate the frequency. So frequency means F is equal to 1 by T. So 1 by 6 into TPD. Now based on the propagation delay time, you can able to calculate the corresponding frequency. Let us solve one question on this previous EC question, previous gate EC question. So for the same circuit, a propagation delay TPD is given, and the propagation delay of each inverter is given as 100 picoseconds. 100 picoseconds. What about the frequency of the generated clock wave? So, but in that question, there are 5 NOT gates are given. So n is equal to 5. In this question, we are using n is equal to 3. The number of NOT gates which are connected in the cascade is 3. But in the examination, the previous examination, they have given 5 inverters are connected in cascade. So F is equal to 2 into 5. 5 is the number of NOT gates which are connected in the cascade, and it is multiplied with 100 picoseconds. So if we simplify this, you will get 1 gigahertz. 1 gigahertz is the output frequency of this generated clock wave. And let us solve some other questions based on the NOT gate. Now, in this, there are 3 NOT gates are given, but there is a feedback only from the second output. This circuit acts as stable. The second option is bistable. The third option is monostable, or D option, all of the above. All of the above. So already we learned whenever even number of NOT gates are connected in cascade with the feedback, that circuit will act as a bistable. Similarly, let us solve one more question. In this question, there are 5 NOT gates are given, but there is a feedback from the third NOT gate. And what is the time period of the generated waveform? Obviously, it will generate a clock signal, but what is the time period? Since there is a feedback from the third, the frequency will be F is equal to 1 by 2 into 3 TPD. Here, there is an odd number of inverters are connected in feedback. So how many odd? That is 3. So 1 by 2 into 3 TPD. That is the frequency is 1 by 6 TPD is the answer. And there is one more similar question like this. Here it is. What is how the circuit acts like? So here it is the first gate is not a NOT gate. It is a buffer. Buffer means whatever the input you are applying, the output will be same. Now, how many number of inverters are contained in cascade? Only 2 inverters. That is even number. Whenever even number, the answer is it is acting as a bistable multivibrator. So I hope you understand the complete information about the NOT gate. If you are watching our channel first time, subscribe our channel and like our video. Thank you.